Hello viewers, in this tutorial I will perform a pipe network analysis by using Ansys software. So basically pipe network analysis, in that we have to calculate the flow rate and the pressure drop in the individual sections. Individual section means individual channels or individual pipe or hydraulic networks. So let's start. Okay, so this is a hydraulic network or pipe network. So in that, suppose a fluid is flowing through this pipeline or this channel. So there is some problem statement and then we have to calculate one by one. So problem statement is the flow rate at a node 1 is a 0.16 LPS. So value is flow rate is given. So first node. So where is the first node? So see here there is a first node. Next is the pressure at a node 4 is a 0 Pascal. So see here at a node 0.16 is the LPS, is a flow rate given. Then this is a second node, there is a third node, and last one is a fourth node. At a fourth node, the pressure value is a 0 Pascal. Then for the given condition, the flow is a laminar. So first assumption is a laminar flow throughout the system. Then calculate using Ansys software the pressure in each node. So a fourth number node is a given. So 1, 2, 3 we have to calculate, and then flow in each element. So there is a 4 element, 1 to 2, 2 to 4, 1 to 3 and 3 to 4. So there is some again value is a given. So dynamic viscosity is a given. So this value is 8 into 10 raised to minus 4 Newton second per meter square, and density of the fluid is a given. Then this overall channel, there is some dimensions and the length of the pipe is a given. So see here 1 to 3 values, L and D values are given, length and diameter of these pipelines are given. So overall system here is a given. So different length, different dia of this particular pipe network, and we have to calculate a pressure drop and flow through the pipe. So flow rate we have to calculate. Before going to Ansys software, there is a pipe network illustration. So in that 1, 2, 3, 4, this is a node, but whenever you have to choose element attribute, so in that there is a different length and different dia. Due to this reason, we have to select 1 to 2 is a suppose element 1, 1 to 3 is element 2, 3 to 4 element 3, and 2 to 4 is element 4. This is the assumption. You can choose 1 to 3 is element number 1, whatever you can move. So go to Ansys. In Ansys software, click on preferences, and preference is Ansys flood. Click on OK. After go to preprocessor and add element. In that element we choose Ansys flood and choose a viscous, okay, 3D viscous 138. Click on OK. Then go to real constant, add a real constant. So there is a 4 element, 1 to 2, 1 to 3, 3 to 4 and 2 to 4. So click on OK. So lateral dimensions or radius dimension 1. So dimension 1 indicated as the radius of this pipe, and dimension 2 is indicated as the length. So real constant set number is a 1. What is the value? First value is a 7.5 e raised to minus 3. Then length is a 7.5 meter. Click on OK. Don't apply. Then again add another element, a real constant set number 2. And here the radius value of this pipe is 10 e raised to minus 3, and length is a 10 meter. Click on OK. Again add third element. So in the third element there is a value 5 e minus 3, and the length is a 7.5 meter. Click on OK. Again add last element, fourth number element. Here is a 6.25 e raised to minus 3. This is a radius, and second length is a 10 meter. Then close now. Go to material property, material model. Then click on fluid viscosity. So viscosity value is 8 e raised to minus 4. Click on OK. Go to material, exit. Now go to modeling, create a node, because there is a node is a given. So node in active CS. So first number 1 value is 0, 0 suppose. So see here. So this value is suppose origin position, and toward the right and bottom side and toward the right again. So I have to this node number 1 is the origin point. So initial value is 0, apply, go to second point, and second value is 0 for x direction, and y direction minus 7.5 because the downward side, apply. Then third number node, this value is x is 10, y is 0, then click on apply. Then next number, fourth number value or fourth number node is x is 10, y is minus 7.5, click on OK. So I have to create a 4 node, then go to element, then auto number through nodes. So 1 to 2 is element number 1, so choose carefully 1 to 2, click on OK, then go to element attribute, then choose a real constant set number is 2, click on OK, go to again through nodes 1 to 3, this is the node number 2, again go to element attribute, then go to set number 3, click on OK, again through node 3 to 4 is a third element, and go to element number 4th and through node again, and 2 to 4th is element number 4. So choose carefully whatever you want, where is your element number, so choose element number through the nodes. After this modeling is done now, go to load, then define load, apply, in that float ANSYS, and this node number 1 is a flow is a given, so on a node select node number 1, click on OK. So what is the value of flow value? So there is a 0.16 e raised to minus 3 meter per second, then click on OK, then go to pressure drop or pressure degree of freedom on a node. So fourth point is the pressure drop and value is 0 Pascal. So pressure value is 0, click OK. So load is done now, go to solution, then solve current load step, click on OK. Okay, solution is done now. After solution is done now, go to general post processing, then go to plot result, contour plot, node solution. In that node solution, click on a degree of freedom solution, pressure value, and see here there is a pressure value. Okay, so maximum pressure is 1724.77. Here is the pressure value in the Pascal. Then go to element solution and go to fluid flow. Okay, click on OK. So this is a fluid flow. Then go to again list result. Click on the nodal solution, degree of freedom solution, pressure value, and after selecting the pressure, see here there is a node number is 1 to 4, and there is a different pressure value. So first node is a 1724.8 pressure, then pressure, second element is a drop, then third element is a rise, and fourth number pressure is a 0. Okay, go to again element solution, then fluid flow, click on OK. So there is a element 1, element 2, element 3, element 4, there is a different node, a different fluid flow value. Okay, then go to reaction solution, then flow rate, click on OK. So what is our initial flow rate? Initial flow rate is a 0.16 e raised to minus 3 meter per second. So this is the active side, a reactive side is a minus 0.16 e raised to minus 3. Okay, so this is done now. If you like our videos, then please subscribe to our channel and click the bell icon. Don't forget to like, comment and share. Thank you very much.